we are going to calculate how much deviation will be there of a charged particle when it moves in a magnetic field. You know, the motion of charged particle, its direction of motion at any instant can be determined with the help of Fleming's left hand rule. And all these calculations done before, where we have seen that the radius of the charged particle in the magnetic field R is equal to mv by bq, and time period equal to 2 pi r by v. This is equal to 2 pi m by bq. Isn't it? R by v is m by bq. You just substitute time period. On it we have calculated the cyclotron frequency also. That is equal to bq by 2 pi m. All these are known. When it enters a charged particle, all these will happen, and the working of cyclotron, all these things also we have done. But what we haven't done there before, that what is the deflection produced in the charged particle, because you can see that when it enters the magnetic field, suppose it starts from here. This is your x-axis you fix up, and this is your y-axis you fix up. Then at the point P, when it goes, what is this distance x and this distance y, that we have to find. How to find the x and y? Displacement along x-axis and displacement along y-axis. This we are going to discuss here. Okay. How much distance it will travel along x-axis, how much it will travel along y-axis. Okay. So we are taking another diagram over there where charged particle enters according to our consideration, assuming this manner. This is a crossed field over there. If a charged particle enters, the formal problem, it is better to tell you. The charged particle enters here at this point. You know, it will describe a circular path here. I am just drawing a part of it. The question is, how much distance it has traveled along x-axis, how much distance it has traveled in this direction. Axis may be taken anywhere. Along x-axis, how much displacement? Along y-axis, how much displacement? That we need to find. For our convenience, we are taking the y-axis this manner, where the center of circular path will lie. So at an arbitrary point P. So here the problem, you can start this manner. It just proves the problem. Suppose V equal to given as V0 into I and B equal to B0 into minus K. Because I have shown here it is minus K only going into plane of paper, isn't it? How much sideways deflection will be there, that we are interested to find here. If V is equal to V0I, obviously particle is released so that it has initial velocity along x-axis. Along x-axis it's moving with velocity V0 and magnetic field strength is B0. Then the question is how much distance it will travel along x-axis and along y-axis. I have to remember all those facts which I told you earlier, that omega factor, because here it will describe a circular path whose omega is well defined. How much is omega over there? If you know t, then omega will be what? 2 pi by t. 2 pi by t means bq by m. So its omega going to be BQ by M. Let us calculate the value of x, the position and the velocity, both. I have joined from center to this point. This is radius of course. This thing is also radius. And imagine that from the initial direction, it is deflected by an angle theta. Is the diagram clear? This angle is theta. This is y. This part is x. This part is x. You need to find both x and y so that you can write r is equal to xti plus ytj. This we can find. Xt going to be what? Along x-axis, the factor v0 this x means this is also x in the diagram. Now if this angle theta, by using plane geometry you can see that this is theta, this is 90 minus theta, this angle is also theta. If the deflection angle is taken as theta, then this angle going to be 90 minus theta, this one. This angle will be theta. Sorry, I did a mistake there. If this is theta, this will be theta. This angle going to be 90 minus theta. So this angle has to be theta. Then what is the value of x in diagram? You can see that x by r equal to sine theta. Okay. So x is equal to r sine theta. And in the diagram, what is y? This center you don't take y because these two are matching, then center you take c. C to O distance is r. In figure, y equal to how much? Y is this part, no? This part is CO minus this thing. This thing. This thing is how much? This thing is r cos theta. So, CO part is r and this is r cos theta, then this is y, means this part is also y. This small part is y. So, y is going to be total distance r minus r cos theta. Isn't it? So, you can write x is equal to x. xt equal to r sine theta, but theta stands for omega into t because angular velocity omega is there and the value of omega is known, bq by m. So there will be bq by m into t. Okay. So there is xt equal to r sine bq by m into t and y equal to r minus so one can write r equal to xt plus yt into I cap into j cap. Okay. So values of x and y found, position vector is also found. Can you write an expression for velocity? The velocity is going to be equal to, velocity going to be what? Velocity is going to be Vx Ti Vytj. Vx is how much there at the point P? If the velocity is V, then Vx is V cos theta I cap V sin theta j cap. Okay. Therefore, Vt going to be V cos theta is omega t again. So Bq by mt I cap Bq by mt j cap. Okay. This is the expression for velocity of the charged particle in a magnetic field. If the field applied as shown in diagram, many sums can be set based on this concept. Immediate application you are going to find in one problem. You just copy it down if it is required, otherwise go for the sum straight. In one problem, just solve this problem, one example. Let applied field be equal to minus V0k, V equal to V0I minus V0k. Then your problem is to find the position and velocity after time t. Okay. This is the magnetic field given in a region. Charged particle enters this manner. What path it will describe? Probably you are aware of it. It will describe circular path as well as it has some motion in one direction. We are taking right-handed system. Normally this right-handed system famous in mathematics, but this particular sum, because I want to draw a circle over there, no, it will describe path in x-z plane. Now to discuss its motion, we must go for the magnetic Lorentz force, Fm equal to, and you can find the angle between B and V. Can you tell me what is the angle between B and V first? If it is 90 degrees, then the case is like previous one. If it is not 90 degree, it will follow helical path. Okay. Angle between B and V. Let us find it first. B theta. Initially you check. Then for cos theta, how can you find? B dot V by B dot V is how much? This is going to be B0 V0 by mod B is B0, mod V is show theta 45 degree. Okay. So here the case will be that, and let us find this also. Then you will decide Q V cross B. Let us find, because magnetic Lorentz force is this. Fm will be Q this cross minus B0 K. Check once what is happening there. Fm going to be what? So Fm going to be I cross K J minus J. So it will be Q V0 B0 J. Isn't it? So it will experience magnetic force in this direction. But it will describe a circular path in this plane. So the point, the way we did in the previous problem, what is the sum? This way. Same thing will be there also. I just draw a similar diagram over there so that your understanding will be better, so that you can get this way, because we have calculated based on this. This x coordinate you all can find, y coordinate you can find, z coordinate also you can find. Along y-axis the magnetic force it is experiencing, you know, and if we consider that after time t, then the similar diagram will be there, but one additional motion will be there for the charged particle. Draw the tangent and try to describe. Okay. This is the center of circular path. If this angle is theta, this is going to be theta, 90 minus theta, this angle is theta. Can you write the expression for x and z? Just we did. X and z you can write. Describe circular path in x and z plane. So write the expression for x, write the expression for z. Just do it. Just the way we did in the previous sum. Acha, one thing, will it remain there? Move along. Okay, whatever I have taken based on this you calculate. Velocity will remain in IK plane, no? So x, z you write, and then you write r in terms of x, y, z.